Welcome to this webinar. Lots of people are already in, so maybe we'll give it a while that everybody can join us. Welcome to this webinar of Secura, and we will start any moment. 1 minute, please. I can already start on the house rules. So after this presentation, we will like to answer all your questions. You can send them in the question box, and Robert will try to answer all the questions. If there are any questions left, we probably will provide you all the answers via email. And after the webinar, you will also receive an email with a request for a survey. So we please like to hear some feedback of you on our webinar. So I see still people joining our webinar. Give it a while. Shall we pass now the 1 minute? So I suggest now we will start. So welcome to this webinar. Today we will talk about software development and secure software development specific. My name is Heiko. I'm a sales at Secura. My colleague Robert will talk to you about, he's the manager of our tool and innovation team, and he will inform you about secure development, and I hope he will inspire you today. So Secura provides insight in your digital security. That's what we do on a daily basis. We got 100 employees. We are over 20 years old, and we have 2 places. So we have offices in Eindhoven and Amsterdam. And in our work, we like to use as much international standards. We have a holistic view. So besides technology, we also focus on procedures and the process and people. And we are very proud that recently we became part of Bureau Veritas. That was in January recently. So that's very nice for Secura. Our market teams, they focused on specific sub-markets. So not only sales, but also as consultants work within their market teams. So they focus on technology or industry or public customers. So they understand what your challenges are. And it can be challenges on IT, IoT, but also on OT. And in all these markets and products, we have special offerings. And those are of course, our audits like DigiD and NEN and ISO audits. We do lots of certifications of IoT products like Common Criteria, IEC 62443. Testing, of course, pen testing, vulnerability assessments up to red teaming. And we provide also some tooling like secure file exchange, or SIEM SOC assessments, and forensics. And I think now it's the time I give you a short overview of Secura offering, but you're all waiting for my colleague Robert to inform you about secure software development. Robert, go ahead.
Thanks a lot, Heiko. So today this webinar will be about secure software development, and we start with this overview. The first thing is shift left. What is it actually and why is it needed? Then I'm going to discuss how this security fits in all the different stages of the secure development lifecycle. How to get started is the third topic to make it practical. So first of all, what is shift left and why it's needed? So let's look at a typical software development project without shift left. We're working on a release, we're having a backlog, and we're coding, and we're preparing for a release, and there's a pen test just scheduled before we have a release. And everything is nicely going to according to plan. Things flow nicely, and at some moment in time, we're almost done. We're testing what we have made, but there is a bottleneck because we can't do a security test before the release is done and prepared and built. So we can't do the pen test yet. Luckily, there's a moment that everything is done, and there is an external security test going on. Exciting times. Will something be found there? And yeah, then the results get back, they're being analyzed. Now, can we release? Unfortunately, there are some security findings. And now what to do? Basically, typically you have three different options. The first one is to work extra hard during the weekend, during the nighttime to make the release. We can obviously also postpone the release. And the third option is just release with security issues in there. Now, these are three bad choices, and this is the reason why we want to do security more holistically and earlier in the flow. And that is what shifting left is about. We want to get from here, where we do security in the verification stage, or even perhaps when there's an incident reported when we are already released. We want to move towards here, where we do security already in the design phase and in all the different phases of a software development lifecycle. Now, the picture that we have here is a picture derived from OWASP SAMM, the software assurance maturity model, and it consists of 5 different business functions: governance, design, implementation, verification, and operations. And each of these business functions contain 3 security practices. And we go over in this presentation, we go over these different aspects where security fits in. One more thing on OWASP SAMM. It's an open security model, assurance model made by OWASP, and it tries to be measurable by defining security levels and maturity levels for every stage. It tries to be actionable by providing clear pathways to do things better, to improve. And it's versatile, so it is agnostic of the technology or the processes or the organization it's applied to. There is a downside though. It talks about the processes and not about the how to do it exactly. So this presentation also tries to go into the details of how to do it once in a while. So security should be part of every stage in the software development lifecycle. So let's go over all of these business functions, and let's start in the design phase. And to do that, we first want to know what security is. And here we define security as being protected against threats. And that with this definition, it's clear that 100% security is not possible. You can't know all the future threats, and there might also be trade-offs between, for instance, usability or performance or privacy with regards to security. And it also needs to be cost efficient to implement all the security features. So it's not about being 100% secure, but being secure enough. And to make that judgment, it's important to know the threats up front. The technique that we promote within SecurA to do that is derived from Microsoft. It is a technique called threat modeling. And in that, we try to think like an attacker, or more importantly, try to think about the things that can go wrong. And there's a process in place, because we're not all attackers, some kind of recipe to apply this to your own software. And that is by creating a diagram, then using the diagram to identify potential threats, addressing the threats, and then checking if we did the right thing. For the identification, we use a method called STRIDE, also from this Microsoft threat modeling. STRIDE is an acronym, and it uses the letters, the S for spoofing, pretending to be someone else, the T for tempering, and that is changing some data. Repudiation is the ability to deny a certain claim. I did not press that red button, for instance. Information disclosure is accessing information that you should not have access to. Denial of service is making something unavailable, and elevation of privilege is doing something you're not allowed to do. And linked to these different attack types are security properties that you might have in place, such as authentication to prevent spoofing, confidentiality to prevent information disclosure, and so forth. So to apply this, let's have a look at a simple user story. As a participant, I want to listen to a software development lifecycle webinar. Questions you can ask, as for spoofing, do I need authentication? For information disclosure, is the webinar confidential? Should it be available? Is there a problem when there's a lot of downtime? And if I can listen to this single webinar, can I listen to all other webinars on GoToWebinar? So that's elevation of privilege. Now, these threats can easily be converted into security requirements. And that's what I'm going to show in the next example, in which we also going to use this diagram. So this example is about a Internet of Things firmware updater. You can think of a smart fridge or a smart coffee machine that checks for updates regularly. And this device, there are three user stories defined here. We want to check for updates when there's a new update. We want to download it, and then afterwards we want to download and install the downloaded update. Looking at such a system, we get a picture like this. This is a so-called data flow diagram. And here we focus in view of the time only on the first user story, and that is that we want to check for a new update. And we're going to focus on the two top blocks, the update server and the update loader. And essential in this picture is the red dotted line, which is a so-called trust boundary. And when things cross a trust boundary, it gets more interesting because you can't trust the things on one side of the trust boundary compared to the other side. So let's apply Stride, the letters of Stride, on that interface and see how we get to security requirements from there. So I want to check for updates as an update loader towards the update server. I don't want to just download updates from any server. It needs to be the right one. So we don't want to have spoofing there. So that's the first one from Stride, spoofing. The next letter is the T. Tampering, we don't want to have a fake update. So the update file itself should not be tampered with. And perhaps even might to have a certain format that we want to predefine. Now, this is the letter S and the T, and we can go on with the rest of Stride. In view of the time, we keep it like this. And we're going to have a look at the mitigations or the requirements that derive from these questions. So I only want to check real update servers. Well, I might use TLS certificates to authenticate the server. I don't want to have a tempered file. Well, perhaps we can just use the update information as a compressed zip file that is digitally signed. Now, these might not be the best solutions, but that's not the point here. The point is that we now get to requirements based on the Stride and the threat modeling. And the nice thing about it is that we haven't written a single line of code. So we are deriving security requirements before we actually started coding. Slightly more on addressing threats. What you saw was some mitigations, but there are also other ways to do it. We can really eliminate the whole threat. We can also move or transfer it by, for instance, having an insurance for it. We can accept the risk, and the thing we should not do is just ignore it. And keep in mind that when you do this in the design phase, it might result in a complete redesign to be able to mitigate or eliminate a certain threat. That's why it's important to do this already in the design phase. Because we want to get to security requirements in this stage. So we have functional requirements, that's what we're used to do, but we also want to derive security requirements that basically describe what should not happen. And the nice thing is there are standardized requirement lists, for instance, the Application Security Verification Standard, ASVS, or the mobile version of it, MASVS. And the nice thing of these security requirements is that they can later be used in requirement-driven security testing. When we decide what kind of technology we're going to use, we get for free new threats. And we can apply threat libraries to and additional checklists to derive even more requirements for the security. And in this phase, it's also important to know secure by design principles and to use within a company standardized ways to address certain things, for instance, using the same kind of technologies or frameworks. So from the design phase, we go to the implementation phase. And in the implementation phase, we look at secure builds. And in secure build, we want to have a reproducible build process that is as much as possible automated. And part of that automated build pipeline, there should be tests that are automatically run within the pipeline. There are different kinds of tests that come to mind here. The static testing that is applied to the code itself. When the code is run, you can look at the dynamic testing. That's the dust kind of testing, and the interactive application security testing, the EAST, promises to combine the best of both worlds by looking at the code and then looking to the running code based on that code to be even more efficient. It's not a silver bullet because there are always a lot of false positives in these tests. But it is a very good approach, and when we do pen tests, we often find issues that could have been found by these kind of tools. And we recommend to ensure that the build fails upon security issues within the pipeline. Another important part on the implementation phase is third-party software. We all use them, and they're being used more and more. And the problem is that the security of it is unknown, and it's very difficult to verify that all, because if we would have time to fully verify the security, we could have built it ourselves. So the best we can do is check for vulnerabilities, and we can do that by a so-called software component analysis, which is checking that these third-party dependencies do not contain vulnerabilities. There are a lot of tools available for the specific programming language that you use, and they can very easily be integrated in the build pipeline. Last part on secure deployment. It is important to ensure that the things you build are really the things that you are putting into production, and they are not compromised during the deployment phase. And to do that, the best way is to automate the process as much as possible with a lot of attention on secret management. Who has access to your deploy keys or the other secrets that you use within your code? Are those secrets ever revoked, or are they expired? Will previous employees that worked for you still be able to go to your production environment or to change the build pipeline because they know the build secrets, for instance? And that is very important and relevant, shows the big SolarWinds exploit that was related to this FireEye hack lately. And from Wikipedia, here too, the attackers used a supply chain attack. The attackers accessed the build system belonging to the software company SolarWinds, possibly via SolarWinds Microsoft Office 365 account. So the way this was hacked was not by having a backdoor in the code itself, but by changing or adding the backdoor in the build process. Last part on the implementation, defect management. It's important to collect as many things you find during the implementation phase to get insights from it to go to action. Based on the information you get, you can also, from one application, you can also apply that to other projects within your organization. So the next phase, verification, where we typically did all the security testing. First of all, the requirements that we derived during the threat modeling phase. There we can make nice test requirements for kind of unit tests for security. And there are different ways to describe them. On the left side, you see a test that's called without a valid token, the page should return a code 403. And that's very good to test, very clear. And you can also easily calculate the coverage you get with that. when the requirement would have been account information must not be visible to others, it's way more vague, and probably we need to touch all code to ensure that this is actually the case. The left side is a positive requirement that is the best way to do it. The right side we often call anti-requirements, and that's not the way to do that. The generic security testing is basically testing everything we didn't thought of before. And there are the techniques that we used before, like a pen test from an external company, a fuzzing test, perhaps some business logic test, or security stress testing, denial of service testing, these kind of things. The release or operation phase. Operational management, where are these applications deployed? Perhaps to an unsupported operating system, perhaps there are unpatched servers, or if the server is done correctly, perhaps the backup media is not stored in a secure way, or no backups are made at all. And it's important to note that in this phase, even if you did everything right up to here, any of these items can make all the protections built into your application completely irrelevant, because the underlying operating system or environment gets hacked. So you want to harden your environment you deploy to, you want to ensure all the patches are being run, and you want to monitor that actively. So you want to monitor the activities, the configuration, patch level, status, security incidents that you might have on your application. And in my software team, we have the rule that if it isn't monitored, it isn't production. Then perhaps we did everything right, but there is still a security incident. And for that, we want to have incident management in place. And incident management is great. We want to detect the incidents ourselves, preferably by having automated logging and monitoring. If we can't find it or didn't find it ourselves, we prefer to have a responsible disclosure program such that helpful hackers help us to tell what the issues are. But even if it is coming in via another way, we need to have some formal process to respond to these incidents. For which you want to have predefined roles and predefined responsibilities, and you want to dry run that before it actually happens. And we'd like to suggest to have a lot of attention to what you can do when you do the incident management dry run, whether you can actually figure out what happened. So are the informations that you need to figure out what happened, are they logged, are they present? And we want to, we call that being forensic ready, to ensure that you can actually do a forensic investigation if a real incident happened. Finally, the governance layer, how things are organized. We all know that under pressure, even if you have the best intentions, security might not come to the first place. We're tempted to skip them. And once in a while, that's not a bad thing, perhaps, but in general, we want to use security and to have security in all the phases of this software development lifecycle. And to do that, we can do a number of things, creating incentives to do this. For instance, setting up internal standards, how you want to apply this. Also know your external compliance drivers. And here I listed a few things that you could do. For instance, enforce that there are always 5 security points in a sprint, or having a test coverage on your security testing of a certain number. How to organize this? You want to have a person that drives this, and we like to call that a security champion. Security champions are embedded in a team or closely involved to the team, and have experience in security and can really drive the security culture. It's important, though, that this person has support on all levels to be able to coordinate between the different teams. And for that, obviously, education and guidance is required in all the things I have discussed today, the whole software development lifecycle, from secure coding practices to threat modeling to how to deploy in a secure way. We give a lot of training courses, and we notice that doing regular training courses works much better than doing it once, and that hand-on training is much better than only the theory. So doing some hacking, real-life hacking, works better than just looking at the theory. So to make it practical, how to get started, how to measure, and how to improve. And there's a 4-step approach: getting support in your organization, finding or recruit these security champions, never stop learning, and motivate by measuring and the improvement. So first of all, support in the organization, because without support, it's very difficult to set this up. And for that, you want to have a positive, secure software development lifecycle business case. And that depends on the organization. Some organizations perhaps want to be in control, so that is the reason to do secure software development. Perhaps it's a lot of time spent on incidents, and that is the point that needs to be improved. Or perhaps there are external compliance drivers or bad publicity in the past to have a positive business case for doing secure software development. And it might also be a risk of fines, for instance, on the privacy. So next step in to make it practical: how to find or recruit a security champion. Well, they're hard to find, we notice, and when we provide training courses, there are always these people in these courses that have a above average interest in the security, are intrinsically motivated, and we would suggest that if you don't have a security champion yet, that you try to nominate those people to become your security champion. They might need to have a little more training on it, but those are the people that can really drive this and promote security. It is important, though, that they have the authority to get things done, because else it would be a big demotivator for your security champions. Never stop learning. Software development is a quickly changing world. New techniques pop up every day, and developers need to know the latest on how to work, for instance, with certain programming languages, frameworks. Need to patch. The same goes for the operation or for the DevOps. They all need to know how things work, especially when we move to the cloud and things are new. Then it's important to learn and to know how these things work. There are many resources to learn and to keep learning. There are many books, free to use websites, obviously also commercial training courses available. There are 2 things I'd like to point towards, which are the OWASP cheat sheets. For a lot of subjects, they contain a very valuable information considering the security of programming languages or certain exploits and how to prevent them. And another OWASP project, which is called Security Knowledge Framework. I have a screenshot of their website. It's free to use. And it consists of a lot of things, including code examples, ASVS-based checklists, labs, which you can practice certain types of hacks on, and a huge knowledge base. So this is highly recommended if you are a developer and you want to know more about a certain subject. So how to keep these things going? That's by motivation, and the best way to motivate is by making it fun. For instance, using team competitions or hacks, hackathons, or capture the flags, and by measure and show that there's improvement. Because if you keep measuring and you keep seeing improvement, that's a real motivator. And we can have a look at different things to measure, for instance, the number of open security issues or the amount of security story points we have been able to work on. And more organizational wise, we can use the baseline measurement using this OWASP SAMM. And the nice thing there is that it contains, for all these business functions, it contains a checklist and a toolbox in which you can answer questions and you get to a score. And that makes it very measurable, and it also provides a clear path for quick wins and to improve. And it's really a great tool to make your SDLC measurable and define the quick wins. Whether you are already doing this and want to improve, or just start and want to know where to start. So that brings me to the summary, the key takeaways. First of all, security is essential in all stages of the software development lifecycle. Start your secure software development lifecycle by first ensuring support in the organization. Identify or train somebody who can actually drive this, a so-called security champion. And lastly, find the quick wins and continuously improve by making the secure software development lifecycle measurable. And with that, we came to the end of this webinar, and we are now open for questions. You can ask questions in the question box, and Heiko will read them to me, and I'll try to answer them as good as possible.
Sure, thanks, Robert. Very nice. Yeah, there was a question of Abdallah. His or her question was, who do the pen test of your services? I asked him, which services do you mean? He or she says, any services, don't have services, websites, email, system in general. So who do the pen test of your services?
Who should do the pen test of the application?
Yeah.
Well, you can do it internally, obviously. You can do an internal pen test, but in general, we promote to do it externally because that gives a clear view, a new view on possible issues. You don't have your own blindness of the things that you have been working on yourself.
Yeah, sure. And as Secura, we're a specialist. We say,
of course,
use our services. We're objective, but yeah.
Yes.
Sure. Okay.
Yes. Yeah, for sure.
Been in the same region, yeah, sure. Developers, you have some teams, but do you need a hacker inside your teams or a hacker inside your company, or how do you think about it?
Whether you require to have a hacker within the development team to ensure that you do software development in a secure way? That's okay. Well, that's a good question. Let me see. It's not required to have a hacker in your team, although it helps a little, because you get a perspective to thinking like an attacker. Now, you can also train that or use these checklists, for instance, from ASVS, because that is also a great source of having possible threats, possible vulnerabilities. So you don't per se need a hacker for that. So I would argue it's not necessary. It does help to have somebody with more security knowledge, and the security champion does not necessarily need to be a hacker, but it does help if he or she has a lot of security knowledge.
Okay. Another question within this region is about, I trained my developers. Is that okay? And now the next step, how about that?
You trained your developers.
Somebody already did, so they're thinking about secure software development. You said something about stages. I can imagine there is a next step.
Can you repeat the question, because I don't quite get.
We already trained our developers, and now what is our next step?
Okay, so training the developers is obviously an important part, because the developers need to provide and create code that is built in a secure way. But that's only part of it. It needs to be deployed. It needs to perhaps go into the cloud. That needs to be secured in a good way. Now, all the different stages I mentioned before are important, and if you did everything right and somebody managed to get a hold on your build pipeline, and at the last stage compiles a backdoor in there, or when you deploy to an unpatched server and you did everything right, but the lacking of the patching ensures that an attacker is able to take over the machine on which the code runs and still compromises it, yeah, you still have an issue. So just creating secure code is not the end solution.
Okay.
There needs to be more.
So it's not only your developers, but also your IT department, etc.
Yes, yeah. And in general, that's combined in DevOps or in SecDevOps. So it might be the same team. It might that could be, but all these different parts are important. And if you an attacker only needs to find the weakest part.
Yes. I see we have 10 minutes left, but we have several questions now. And all of a sudden, everybody thinks about questions. So, question about Victoria. She asked, how do you get value from measuring security story points? Trend-wise, a decrease or increase of such points could be positive as well as negative. Yeah,
correct. We promote that mostly to ensure that within the implementation phase, the day-to-day activities and a lot of pressure on making features, by mandating or by suggesting that there are always a number of story points within a certain sprint, we ensure that there's attention for security. I agree that if it gets progressively worse and you need to do more on security, that's not a good thing. But we make it mostly as an incentive to require security as part of the day-to-day tasks, basically.
Okay. Jeffrey had a question. Can you name some tools that will automatically check third-party dependencies?
Yes, there is the OWASP dependency checker, but there are a number of these tools for your specific language. If you use Python, for instance, there's a tool called Safety, yeah, it really depends on the language that you use. For NPM, you have NPM audit. A lot of tools that just do a check on known vulnerabilities, and they're specific to a language. They're paid tools, but they're also open source tools. Yeah.
So Jeffrey, if you want to have more information about that, we get in contact and we'll
based on the specific language,
yeah.
We can point you to the right one. Yeah.
Okay, excellent. Anthony had a question. Your example of a good security requirement looked too technical to expect a typical product owner to specify. Do we need to security train them too, or do you see security requirements coming from a different source?
Yeah, that's a good question. When you do it in a threat model session, in which you have both the technical people, the developers, but also management and product owners, then we get to threats, and these threats and the mitigations to it result in requirements, and those are in general much easier and higher level because it's clear what the threat is about and clear to mitigate them. And at the end of the day, that is being transferred into a requirement that says, for instance, when I want to go to the profile page of someone else, I get an error message. But that comes from the fact that we don't want to have elevation of privilege. We do not want one user to see the profile of someone else. So on a higher level, these requirements are quite good to understand. But when it goes into the nitty-gritty details, they get more technical. But that is what a developer can easily do.
Okay, I hope that answers your question. I had another question about Sabre. How to balance automated and manual pen tests in case of fast evolving pipeline.
Yeah.
In case of frequent deliveries, testing every build might become a bottleneck.
Yes, correct. Yeah, that's one of, I said there are a lot of false positives. That's one of the biggest problems with all these tools. The other big problem is that they might take a long time. So you cannot, when you do this rapid development and rapid deployments, you can't test everything every time. And what you can do is run parts of it. So have a subset of all the security requirements and test those every time. And once in a while, before you make a big release, run it all. So yeah, that's in general what's recommended. It is kind of a safety net that you want to run to prevent that something slips in, just like you do with your regular unit tests. So yeah, we do recommend to do it, but just tailor it more to ensure that your pipelines do run quickly. Yeah.
Yes. Okay, I see we have some minutes left. So there was an extra question also again from Victoria. She's very active on this one. How often do you recommend training developers? What is common in your experience? For instance, highlight one topic every 6 months or so. So
yeah,
what's your experience on this one?
There are different techniques, and keeping security top of mind, or at least an important part of the daily operation. Revisiting a few of these subjects, like doing a training on threat modeling, then doing a training on hacker mindset, or ways to do secure coding, or how to use ASVS. These kind of training courses, 2 or 3 in a year, that makes a lot of sense to keep things top of mind. And obviously, when teams grow, then new people that come in, yeah, we get these classes of people that just joined that then need to be trained. But a few times a year to just keep it top of mind. Yeah.
Yeah, there's another question from Jan Willem, but I think you already mentioned something about it. Are there any security testing tools you can recommend, like OWASP SAMM, for example?
Yeah,
but
so yes,
you already mentioned some.
Yeah, no, what I mentioned were tools for the third-party libraries to check those. There are a couple of tools that you can use in the pipeline that do this static testing or dynamic testing, and again, that depends a lot on the kind of application you run. And different tools find different things. So if you use OWASP, they find other things than when you use SonarQube or when you use the commercial tools for this. In general, what we see is a combination of these tools has the best result, although there are a lot of false positives that you need to get rid of the first time. And it takes longer to run all these tools in the pipeline. What was mentioned before, this might become a bottleneck in the build pipeline. But in general, we see that the combination of these tools, like OWASP, helps a lot. Yeah.
Okay. So I think we're about at the end of the questions. If you have any questions left, please send them in. We would like to give some comments on that and inform you. Thank you for watching. I say for this webinar, I hope everybody is inspired, has lots of ideas to get on. So if you want to do something with SDLC, and please contact us. We like to have a conversation afterwards. Here is our contact info. Sure, or your regular account manager at Secura, anyhow. And afterwards, after this webinar, you will receive an email with the request for our survey. So we would like to know if you're like this webinar, and would like to see some follow-up if you're interested about this subject. Well, thank you very much and have a nice day.
Thank you.